lecture 1 we discuss about the chemical process industry and especially with reference to organic chemical industry, what are the products, what are the development that has taken place. And now we will be discussing about the raw material for organic chemical industry. As you know, the chemical process industry is the important role in the development of the country. Chemical process industry uses raw material derived from petroleum and natural gas, salt, oil and fats, minerals, limestone, biomass and energy from the coal, natural gas and a small percentage from the renewable energy resources, because energy one is the important segment in the total cost of production in the chemical industry. As I discussed in the earlier lecture also, that the initially manufacture of organic chemicals started with the coal, that was the acetylene from the calcium carbide root and alcohol from the fermentation industry. Now more than 90% of organic chemicals are produced from the petroleum and natural gas route. This is the development that has taken place because of the availability of the petroleum products from the refineries. But as you see, the things are all these raw materials are becoming more and more scarce. Again we are rethinking to utilize our old raw materials like coal or the biomass or the alcohol for the production of the organic chemical industry. Another problem that has been rising cost of the petroleum, natural gas and continuous decrease in the reserve has spurred the chemical industry for alternative feedstock like coal, biomass, coal bed methane, shale gas, sand oil as an alternative resource of fuel and chemical feedstock. Because you see the shale gas and sand oil, that is the one of the area where they still we are working in other part of the world, they are working to utilize more effectively to increase, because the sand oil is slightly heavier, very heavier crude, and even some of the oil which is available in India, just you take the case of the Rajasthan crude, that is having the high tan acid, high sulfur compounds are there. So these are the some of the problems also in utilization of the new raw materials. Coal remains the dominant source of the energy, because we are now discussed something about the energy resources which are available for the chemical process industry, because you see the without energy nothing can be done, we cannot run a plant. So the energy resources, that is very important. So coal, that was the dominant source of the energy, meeting about the 52.4% of the Indian primary energy needs, while oil and natural gas met the 41.6% of the energy requirement in 2008-9. Power sector accounted for 77% of the non-coking coal offtake. As per Planning Commission projection, till 2032, coal will continue to have a dominant share, meeting over 50% of the primary commercial requirement. World and India energy consumption scenario, that is in the figure M module 1.4 that is given, that you can go through. The world energy consumption is projected to increase by 58% over a 24 years period from 2001 to 2025. Total energy use is projected to grow from 404 in 2001 to 640 quadrillion BTUs in 2025. This is how the changes that is taking place because of the fast development that is taking place. In India's requirement of fossil fuels by 2000 is estimated by various agencies is in the range of 336 to 462 million tons of the oil, 99 to 184 million tons of oil equivalent of gas, and 602 to 954 million tons of the coal. That is the requirement that is projected. This is the scenario of the oil and gas and the hydropower, nuclear power we are using on. So nuclear power, that is actually the small portion of the total energy requirement that we are having. This is the how the changes that has taken place in case of the chemical feedstock, the raw material which we are using. In the past we started with the coal, salt, molasses, natural rubber, cotton and the fat. These were the some of the raw material in the past. Present gaseous, natural gas, condensate, refining gases, coal bed methane, liquids, naphtha, solvent extracts, middle distillates, solids, coal, coke, wax and residue. These are the present raw material that was. The future again we are coming in the big way for utilization of the alternative raw material, that the biomass, coal, crude oil and distillate. This is the coal bed methane, gas hydrate, shale gas and algae as a fuel. Again the people are working for production of the alcohol based on the algae. So that the more, but only the problem the cost of the production of the alcohol through the algae route. So now the future raw material that may be algae also. Primary raw material, because the raw material which you are using that may be primary or the secondary raw material. So gaseous, natural gas, condensate, refined. Condensate that we are getting from the heavier fraction of the natural gas while processing the natural gas. And now some of the units are coming from the ONGC who are going to utilize the condensate. Some of the condensate are rich in the aromatics, we can extract the aromatic from the condensate. Then the refinery gases, coal bed methane, gas hydrate, liquids, naphtha, kerosene, gas oil, middle distillate, solids, coal, coke, wax and residue. Oil and fats, tallow and the coconut oil, palm oil and other oil that we are using in case of the soap industry, biomass, alcohol, paper, energy that we are we are using, and some future scope is also there for biomass route. But the alcohol route from this your molasses, that is still we are having the more units, and most of the alcohol part that we are making from the biomass are the, but from the biomass to alcohol, that is one of the again big challenge, because the lignin is there, removal of the lignin, pre-treatment part, the cost of the pre-treatment of the biomass is more, but lot of the work that has been done, and so the in future we may have some biomass based alcohol plant also. The salt, from the salt, as I told you earlier also, the sea is rich in the resources. It may be whether oil or the minerals or the salt, and these salt that is being used as a raw material. If you take the salt, salt is a very small, you will find that what is the use of the salt? It is not only for the edible purposes. Large number of the industry, they are based on this salt as a raw material, and product from these industry, that is the backbone of the many chemical industry, just like the chlorine, caustic soda, soda ash. These are the product that we are using in some or other form in most of the industry. Sulfur, that is the sulfuric acid. Now the sulfur, instead of sulfur, the pyrite is also coming in. Some of the units which are just like copper or the iron units, they are using the iron and the copper pyrite also for the manufacture of the sulfur. And the fertilizer industry, they are using sulfuric for the making of the ammonium sulfate. Limestone for the manufacture of cement, lime that we are using, and lime, that is also again a raw material for many of the chemical industry, and one of the major use is also in the paper industry for during the recovery of the chemicals. Paraffins, methane, propane, butane and higher hydrocarbon, because now the paraffins are also the people, because the methane that is available in the natural gas, propane that we are getting from the various process, even in case of the natural gas is there. So how to convert this methane or the propane to the more value-added product? So from the propane to propane, methane to olefins, these are the things that is happening, these are the development that is taking place. Olefins and derivatives, ethylene, propylene, butadiene, alcohol, vinyl chloride, these are the acetic acid, vinyl acetate, etc. These are the some of the actually the chemical intermediate which are finding large application in making of the large number of the chemicals. Aromatics, benzene, toluene, ethyl benzene for styrene, xylenes, various, especially the ortho and the paragen, they are very important. Naphthalene, that is sometimes actually naphthalene that we are getting from the coke oven plant, and so naphthalene is one actually the route for making of the phthalic anhydride is the naphthalene also. So, that although we are making from the orthoxylene now, because the orthoxylene is available from the your paraxylene plants. Monomer for polymer ethylene, propylene, vinyl chloride, styrene. These are the some of the monomer from the major polymer which we are making, whether it is polythene, polypropylene or the PVC or the polystyrene, or even in the case of the styrene that is being used in rubber industry. Monomer for synthetic rubber is styrene, butadiene, chloroprene, isoprene. Actually the isoprene that is available in the FCC or the cracker gases, but still we are not recovering about the FCC 8% of the C5C gas is isoprene, which can be recovered and that can provide. And styrene, because the ethylene and the benzene, these are the two raw material for making ethyl benzene and ethyl benzene to styrene. And already some of the petrochemical complexes, just like the Panipat refinery, they are going for the manufacture styrene butadiene rubber. And earlier we used to make the styrene through the alcohol route, alcohol to ethylene and ethylene from styrene, ethylene to styrene. Mono for synthetic fiber industry caprolactam, that is for nylon 6, adipic acid, hexamethyldiamine for the making of the nylon 66. Still we are not making nylon 66, most of the nylon, that is the based on the caprolactam, that is nylon 6, terephthalic acid, and acrylonitrile, that is for the making of the polyacrylonitrile, that is the, because now you are seeing in the woolen industry huge changes, that is because of the polyacrylonite fiber which is having the wool texture and the because of the floppy nature, that the polyacrylonitrile or the acrylonite fiber. Even acrylonitrile does find application making of the some of the specialty polymers and rubbers also. Secondary intermediates mean the products which are getting from the refinery or the petrochemical, that they are being used as intermediates for the agrochemicals, intermediates for the dye stuff industry. You take the case of the aniline. Aniline, that is coming from the aromatic plants where we are using the benzene, and from the aniline, that is one of the major raw material for dye stuff. Intermediate for explosive. One of the earlier explosive used to be the TNT. That was actually from the toluene and nitrotoluene, that was being used as a explosive, and still we are making explosive. So intermediate from RPT, that is also from the, there we are using your this formaldehyde. So this is the how the in some of the primary feedstock they are playing important role in providing the secondary intermediate which are finding application as a finished product. Similarly, you take the case of detergent, paraffins that we are extracting from the kerosene, and the paraffin that is converted to olefins, and this olefin is alkylated with benzene, and so they were getting the linear alkyl benzene. So these are the some of the secondary intermediate that we are using. This is the how the feedstock for the organic chemical industry. It may be the petroleum, coal, fermentation, oil and fats, and the various products derived from the petroleum, coal, or the fermentation industry or alpentency, or from the petroleum, ethylene derivative, propylene derivative, C4 hydrocarbon, synthesis gas derivative, aromatic, cyclic compound, from the coal, benzene, toluene, because the earlier most of the requirement that was made through the coke oven plant, but at that time the consumption was much less, and the organic chemical industry that was not much developed, and the at the same time yield of the your aromatics from the coal is much less. So that was the problem. That was the problem in case of the coal, but as a byproduct definitely still we are using that benzene, toluene, naphthalene, that is also pyridine, because you see the coal is from the coal a large number of the chemicals inorganic and organic that can be produced, and that we are producing through the only thing recovery part. How many chemicals we are recovering, whether it is from the coal tar distillation from the coke oven gases, it may be the manufacture of the ammonium sulfate, ammonium nitrate. This all we are doing from the coal. Fermentation industry, as I discussed earlier also, alcohol, that is one of the very important raw material for chemical industry. Apart from the breweries, food, monosodium glutamate, pharmaceutical, these are the some of the industry where we are using the fermentation process. Oil and fats, fatty acids, fatty alcohols, soaps, glycerine, because the glycerine that is going to be one of the very important raw material in the future for the chemical industry, and still they you can produce a number of the value added products from the glycerine. From the biomass, as I told you, the processing the biomass, there has been some problem because of the presence of the lignin and pre-treatment is required. But the number of the products that we can derive from the biomass, starting from the methane, pyrolysis gas, pyrotic oil, ethanol, food, single cell protein, sugars, chemicals, ethanol, methanol, acetic acid, butanol, vanillin, oxalic acid, acetone. Phenol means phenol, that is the cumin root that you can go. The fiber, paper product, rayon, others activated carbon, mulch and soil conditioner. These are the products that you can get from the biomass. Now I will discuss about some of the products which are getting from the petroleum route and the various petroleum fractions which are being used as a basic raw material in the petrochemical industry. First major product is the natural gas and the refining gas, because there are two sources of natural gas. One we are getting directly from the natural gas. Second is the natural gas we are processing after the processing of the crude oil, which is separate, that we call it the associated gas. Third is the refining gases which we are getting during the various processes. The refining gases contain methane. So these are the some of the natural gas where crude oil distillation, catalytic cracking, catalytic reforming, all the processes we are producing the gases which may find use or that is being used for the production of the chemical. Composition, methane, ethane, propane, butane, boiling point up to 25 degrees centigrade, that is the fraction in the case of the refinery, because after that the gasoline fraction is there. Intermediate process, liquefaction, cracking, intermediate feedstock, LPG, ethylene, propylene, butane and butadiene, which find application in the manufacture of other LPG is that is being used as a fuel, but that can be used for the manufacture of aromatics also through the cycle process. So these are the products which are being used for the manufacture of some of the other important intermediates. Naphtha is one of the most versatile feedstock we are getting from the refinery, because naphtha in the various processes, because you see the gasoline is also a naphtha, but the gasoline higher octane naphtha is only being used as a gasoline or state-run gasoline. Rest of the naphtha you will have to process to more value added product, either it may be through the catalytic reforming or it may be through the catalytic cracking of the naphtha. So these are the some of the sources from the refinery which are getting distillation and the thermal and catalytic cracking, hydrocracking, visp cracking. This is the reason why we call it the state-run naphtha and the cracked naphtha. Both we are getting from the various process, and this is the boiling point range 70 to 200 degrees centigrade. As I told you, in case of the higher boiling point fraction which we are getting as a naphtha, they are having the lower octane number. So that's why they cannot be used as, and at the same time you see the octane number requirement that has been changing. Earlier vehicle 70 octane number, now we are talking about the 100 plus octane. How to meet that requirement? So just for the improvement of the octane number, that is some secondary process that we are doing, that we will be discussing while discussing the petroleum refining and the petrochemical part. So, composition of the naphtha C4 to C12, boiling point 70 to 200 degrees centigrade, intermediate processes which are there, cracking, reforming, alkylation, disproportionation, isomerization, intermediate feedstock that we are getting from the naphtha, ethylene, propylene, butane, butadiene, benzene, toluene, xylene. These are the some of the intermediate products which we are getting either from the naphtha cracking or from the catalytic reforming of the naphtha, or now the in the refinery we are also having the isomerization process where we are mostly it is for the production of the high octane gasoline from the low octane naphtha. Kerosene, although that the kerosene major portion of the kerosene that is being used as a fuel, but a good amount of the kerosene that is required for the manufacture of the linear alkyl benzene. So, the what we are doing the fractionation of the kerosene, and after the fractionation we are taking the carbon atom from 10 to 14, because for the more and more biodegradability this carbon number is very important. So, it may be you can say the C10 to C14 but more preferably C11 to C13 carbon alkanes that will be required for the, and that we are fractionating. What we are doing in case of the LAB plant, we are fractionating the kerosene and extracting this portion of the alkanes from the kerosene, and rest of the kerosene that is being recycled to the fuel system for blending. Gas oil, again that is the heavier portion of the we are getting from the crude oil distillation of the crude oil and the cracking during the process, because what we are doing in case of the cracking or the hydrocracking, braze cracking, remaining portion of the heavy residue which are getting from the atmospheric and the your vacuum distillation count, that is again further being processed in the secondary conversion process for getting more value added product. So, major product that may be cracking, again gas oil cracking that can be also done, but only the cost of the cracking of the gas oil and the product complexity, because the product less ethylene and propylene is there and more heavier packing, that is why, but some plants are there in which are operating on the based on the gas oil for the olefins. So, that may be the one of the source for the future source for the olefin in the gas cracker, because in the reactor also for naphtha cracker lot of the development that has been taken place, again that will be discussed while discussing the petrochemicals. Wax, again that is part in case of the more paraffinic crude oil we are getting wax, and so the wax after the cracking we can get the alkanes which can be used for the further cracked, and we can use for the production of the some of the higher alcohols, higher hydrocarbons. Pyrolysis gasoline, that is the product from the we are getting from the ethylene cracker, means the naphtha cracker, the gas cracker, and that pyrolysis gasoline is rich in the aromatics, and these aromatics can be utilized effectively for the that can be actually mixed with the reformate, and then it can be processed in the aromatic production plant, where we are, because only additional requirement in case of the pyrolysis gasoline, that will be the removal of the sulfur from the pyrolysis gasoline. So, these are the some of the sources in case of the your pyrolysis gasoline, and some of the processes that is involved in case of the separation of the pyrolysis gasoline, that is the distillation, extraction. Hydrogenation means that is the hydrodesulfurization of the pyrolysis gasoline for removal of the sulfur. Crystallization, adsorption, these are the process that can be normally, that is crystallization, adsorption, that is being used for the separation of the paraxylene from metallene. Similarly, extraction that we are using for the close boiling points, aromatic and non-aromatics. And intermediate products, of course, we are getting from this pyrolysis gasoline, the benzene, tyrene and xylene. Petroleum coke, again that as I told you earlier also, you call it the petro coke or the petroleum coke. With the utilization of more and more heavier fuel, now the petro coke production that has been increased, and earlier the petro coke, now because Panipat or the Jamnagar Pani, the petro coke produced, that was being used by the cement plant as a fuel. But now the petro coke that can be used for the gasification, and from the gasification you can produce the synthesis gas, you can produce the hydrogen, or it can be used in the fertilizer plant along with the coal, because the petro coke that will have the higher carbon than the conventional coal. So this is the composition of the petro coke, the various process that can be cracking, reforming and the various separation process, and the product ethylene, propane, LPG and aromatic from the coke depending upon the type of the process you are using. Natural gas and natural gas condensate, already I have discussed some of the intermediate process or residue upgradation process, gasification, especially in case of the natural gas or the heavier fraction of the natural gas, where you can go for the gasification, and the product that you can carbon electrode, carbon that can be acetylene and fuel. These are the intermediate feedstock. Now the alternative routes are also available, because this is the beauty of the nature. The nature has provided the alternate sources, and it is only thing how effectively, economically we can use these raw material for the production of the organic chemicals. Because from the ancient time, even when the no refining was there, some of the organic chemical that was being made, that was through the natural. So similarly, some of the products which you are getting from the alternative route for the your producing of the chemicals, that is the methane from the natural gas, refined light gases that we are using. Alternative route, that may be coal as a byproduct of the separation of the coke oven gases, because in case of the coke oven gases is your this ethylene is there, and so that it can be separated from there, methane that can be separated from there. Of the coal hydrogenation, ammonia from coal via water gas, because here we are making the synthesis gas to CO2, and then, but even in case of the coke oven gases also we are getting the ammonia, and that ammonia that is being used for the making of the fertilizer. So coal based plants also that can be used for the manufacture of the ammonia. Similarly, methyl alcohol, methane, and the from coal synthesis gas, from synthesis gas to again from methane is steam reforming, or the from the partial oxidation, you can go for the manufacture of synthesis gas, and that synthesis gas CO plus H2 that can be used for the production of the methanol, because a lot of the importance that is being given for the manufacture of methanol, because methanol that is not only a raw material by chemical industry, that is also as a future fuel people are seeing methanol. Even the methanol as a blend, as a oxygenate, we are looking for. So that is the development that is taking place, but alternative routes are there from where you can get the methanol. Similarly, ethylene, pyrolysis of gaseous liquid hydrocarbons, dehydration of ethyl alcohol, this is the original route, and even in India we started the ethylene manufacture with the alcohol route, byproduct in the fractional distillation of the coke oven gases, hydrogenation of the acetylene. So these are the some of the, as I told, the acetylene that is one of the rich source of the many of the products that you can, even synthesis gas that can be converted to olefin. The technologies are available, but only thing the economic part that you will have to see. Acetylene, calcium carbide and calcium carbide, because the two routes are there. One is the acetylene you can get from the methane route, second is from the calcium carbide to acetylene route. Both the routes are available, but only earlier it was the calcium carbide. Now you can have the methane from the natural gases, and that can be used for the production of the acetylene, and then further acetylene that can be used as a chemical feedstock, because this is the only alternative route that is available. In case we are not having the petroleum products, then we can go for the acetylene, and from the acetylene only the cost of production is higher in case of the chemicals derived from the acetylene. Then ethylene glycol also from the processes, ethylene that you can get from the processes earlier developed, or the coal via carbon monoxide and formaldehyde route. This was the route for the ethylene glycol. Similarly, the acetaldehyde, co-product, the paraffin gas oxidation, direct oxidation of ethylene, fermentation of ethyl alcohol, and from the ethyl alcohol or acetylene from carbide. These are the alternative route available for acetaldehyde. Acetone, again the wood distillation, or from the propylene. Normally the acetone that we are getting as a byproduct, then the cumin process from the propylene, or the propylene to acetone, that can be there. But alternative route is there, wood distillation, pyrolysis of acetic acid, from where you can get the acetone. Glycerol, propylene route is there, and byproduct the soap manufacture. Aromatic hydrocarbons, aromatic rich and the naphthenic rich fractions by catalytic reforming and direct extraction, or by hydroalkylation, dealkylation, disproportionation, isomerization. These are the some of the aromatic conversion process that is available for the production of the aromatics, and that is being used. But another alternative route is the byproduct of the coal tar distillation, which was the earlier actually the route for getting the aromatics when the refineries were not there, or the crude oil availability was there. Butadiene, again the butadiene, the original route was the ethyl alcohol route, but now we are getting the butadiene as a byproduct from the cracker plant. So ethanol, because you see the styrene butadiene upon we started manufacturing during the 60s in the synthetic chemical Bareilly plant. That was the, now that plant is closed, but they were manufacturing the butadiene through the alcohol route. So this is the how they still the actually your these alternative raw materials that can be used for the putting some of the important organic chemicals which are being used as a feedstock. Routes to produce chemicals, various actually routes which are available for the steam reforming and partial oxidation to produce synthesis gas, cracking and pyrolysis to olefins, byproducts, pyrolysis gasoline and higher liquid gas condensate for aromatics, catalytic reforming to produce mainly BTX from naphtha. So that is the process we are using for the manufacture. That is similar to catalytic reforming, which is being used for the production of the your high octane gasoline. That is the reformate that is being blended with the gasoline, but the same process that we are using, only the choice of the feedstock depending upon the whether our requirement is for the benzene, toluene or the more xylene, depending upon that we are taking the naphtha fraction. Dehydrogenation of the paraffin, ethane, propane, because this is one of the process this is being used for the manufacture of the propylene. That is the alternate route, and a considerable portion of the propylene that we are manufacturing dehydrogenation of the paraffin, and then on purpose actually the propylene that can be other than the cracking route. Petrochemical biomass gasification, gas to liquid technology, methanol to olefin technology, coal to liquid and coal to chemicals, dehydrogenation and alkylation from kerosene, saponification of oil and fats, and recovery of the chemical from the glycerin. These are the some of the routes available. Natural gas, now we will discuss in detail about the individual component which discussed earlier. Chemicals from the methane, chemicals from C2, C4, because different fraction we are having in case of the natural gas. methane and total natural gas, combined reforming with the reformer. These are some of the alternative for the reforming auto reforming process, where the combination of the partial oxidation and reforming is there. Cracking of the natural gas to olefin, and from the gases which are getting C4 and C5 gases, that we can recover the chemicals. Very valuable product. One is from the FCC propylene, C4 C5 gases we are getting butane, isobutylene, butene 1, butene 2, and then the C4 C5. C5 we are getting cyclopentadiene, we are getting isoprene, and some of the other valuable products C5 gases we are getting from the cracking plant. Steam reforming and partial oxidation for the synthetic gas. These are some of the actually the methods which are being used for the, because looking to the energy consumption, because they are very high in this steam. Some of the development that has taken place in case of the steam reforming also, conventional steam reforming, partial oxidation. Now we are talking about the catalytic partial oxidation, combined autothermal reforming, Kellogg heat reforming exchangers, cycler process. Here we are using the propane and butane for the production of the aromatics, oxidation coupling of methane to olefin. This is also the process technology that is available, but only thing that has been not commercialized, because still we are the getting olefins through the other cheaper routes. Gas heating reforming, autothermal reforming. As we discuss about the naphtha, because naphtha that is available, low grade, low octane number naphtha is available on the petroleum refinery, and this is the most versatile chemical feedstock, and its use depends upon the combustion, boiling, and use market requirement. Naphtha remains prominent feedstock. Now whatever the cracker plants we are having, still 52% of the cracker plant are based on the naphtha cracking for the olefin production. So catalytic reforming of the naphtha produces aromatic, which is important chemical feedstock for organic chemical industry, for producing synthetic fiber, pesticides, explosive dyes, intermediate, and plasticizer. Steam reforming or the partial oxidation. Normally both the process that have been used for the conversion of the naphtha to synthesis gas. Cracking of the naphtha, catalytic reforming of the naphtha. This is how the feedstock. You see still the major share of the primary feedstock is the naphtha for the cracker plant. Rest of the component are less. Kerosene, already I have told earlier that the normal paraffins we are extracting from kerosene, and that will be used for the manufacture of the your linear alkyne engine. Here the process for the paraffin, kerosene paraffin pre-fractionation to produce the required carbon number in the paraffins, and that paraffin hydrotreated, and then it is going for further processing for making olefins, and then for the alkylation process. In view of the dwindling fossil sources and increasing cost of the crude and volatile market oil, there is tremendous activity all over the world to utilize the alternative feedstock. And some of the alternative feedstock already I have discussed earlier, that is the biomass, algae, coal, petrocoke, waste plastic, because pyrolysis of the plastic, some of the units are now working for the recovery of the monomer from the waste plastic, and that can be also used for the production of synthesis gas, olefin, and other products. Biomass, again I have already discussed about the importance of the biomass, because of the huge availability from the agriculture, from the forest residue. There is a lot of scope for using the biomass as energy resource through the gasification for the production of the oil through the pyrolysis, fast pyrolysis, or through the synthesis or through the ethanol route for the manufacture of large number of the the chemical, not the petrochemical, because always we are using the term petrochemical, but some of the chemicals which are derived from the petroleum route. Alternative resources will play a growing role, and biofuels, mainly ethanol, are expected to grow fairly rapidly, because you see the biofuels, ethanol and the biodiesel, they are the alternative source of energy also. They are being used, and so the lot of the scope is there in case of the utilization of these resources. Again the same, the biomass conversion of the route for the biomass to heat and power transport fuel, as I told you. It may be the fast pyrolysis, it may be the gasification, various routes are available. Biotechnological route for bioethanol production utilizing lignocellulose material involves delignification, because this is one of the problem, pre-treatment that is required in case of the biomass, the saccharification and the fermentation. So delignification is very important, and that is raising the cost of the alcohol production. And even the lignin which is present, that may create problem in the fermentation. The most common process for bioethanol production from saccharification of the lignin cellulosic involves hydrolysis of cellulose, because the saccharin that you are, after removal of the lignin, we are going further hydrolysis of cellulose and the fermentation of in the same reactor. That is simultaneous hydrolysis and fermentation that is taking place, and rest of the process, that is the rectification, other thing, that is same as we are doing in case of the alcohol. Only thing here, the same type of the distillation column that will be used. Option for the conversion of biomass to fuel and power and chemical feedstocks is, that is in figure, you can see here. That figure is discussed when in the ethanol part, when we will be discussing in detail about the ethanol as the chemical feedstock in the module 3 of the sugar, and not module 3 but module 5, the sugar and ethanol industry. There various alternative routes are there. So ethanol, there are 3 types of feedstock for ethanol: sugar, starches, lignocellulosic and algae. So these are some of the raw material that can be used, but mostly the molasses that we are using for the industrial alcohol. Again, it is not only the ethanol but biomass that can be used as a feedstock for the production of methanol and hydrogen also through the synthesis gas route, the synthesis gas from the gasification of the biomass. Ethanol from the algae, that can be another, as I told you earlier also, we are working, even the Reliance is also working, IIP Dehradun, they have worked for production of the algae from the ethanol. Only thing, the commercial application, commercialization of this process is yet to be done. This is the process which I was discussing about the biomass. Various routes are available: gasification, pyrolysis, anaerobic digestion, fermentation, other process. And so these are some of the final product that you are getting from your biomass. This is the process option for conversion of biomass to fuel and power and chemical route. So as I was saying, direct your combustion, fast pyrolysis, gasification, or through the hydrolysis route. So you can produce, either it can be used as energy or it can be used for the production of the chemicals. Coal, again it is a promising feedstock, as huge amount of the coal reserve is available in India and other part of the world, and already China, they have started one plant, coal to olefin, that has been started commercial production that can be started because the availability of the coal is there. Based on the production of the coal gasification, it will be possible to produce large number of the chemicals from the coal. One constraint in Indian coal, that is the high ash content. But in case of the China, that advantage there, they are having the low ash content and high carbon content coal, and so that is the most suitable for the gasification of the production of the coal. But one route is already available, that is the when you are making the coke, but only thing, yield of the chemicals, that is much less than the other process. As I told you, again we are working and the all over the, because this work for the utilization of the coal as a source of petrochemical, the work started in the 1920, 1930, and again people are exploring just to utilize this coal as raw material. Due to the volatile market of the crude, dwindling petroleum resources, coal is emerging as alternative feedstock for chemical industry, as used coal reserves are available all over the world. These are some of the processes that can be used for the production of the various intermediate which can be used for the production of the finished product, gasification, coal to fuel through FT process, Fischer-Tropsch process, coal to methanol technology, liquid phase methanol process from coal. These are some of the new technology that is available now, methane to MTO and MTO plus olefin cracking process. These are some of the another upcoming process that can be used when the coal is feedstock. Again, I have already discussed about the petrocoke, because petrocoke that is available from the refinery and its amount is increasing because of the use of more and more heavier crude oil, and so this petrocoke that can be a good raw material for the gasification, for the production of synthesis gas, for the production of the hydrogen, and that can be used in the refinery. And the petrocoke that can be through the Fischer-Tropsch synthesis, that can be also converted to fuel. Utilization of the petrocoke offers an alternative to handle higher sulfur, because you see the heavier crude means higher sulfur, and the metal content that is also high in a refinery with the value addition. So that is why the people, even Reliance, that is going for the petrocoke gasification. Reliance already in process of implementing petrocoke gasification to utilize its petrocoke. These are some of the references that you can go through the. The next lecture will be discussing about the various unit processes and unit operation, and what are the chemical technological development which has led to the development of the evolution of the chemical industry. There has been sea changes in the process technology, in the separation processes which was being used in the early in the 19th century and now in the 21st century. So even in the separation process there has been a lot of change. So we will be discussing in the third lecture about the various unit process, unit operation, and that was also how the development in the chemical engineering curriculum took place, and how the chemical engineering was evolved in the industry. because it was the chemistry to industrial chemistry to chemical technology, and from chemical technology to chemical engineering. This was the big role of the chemical engineer, and because of their contribution there has been a lot of the changes in the process condition, purification processes, quality of the product, improving the economy of the process through energy conservation measures that has been incorporated in the development of the various processes, low capacity plant to high capacity plant, that has been done, and so this we will be discussing in the third lecture.